Thank you for coming to this talk. I know it's straight after lunch and everyone wants to sleep, but I'm going to try and assure you that security is interesting and will keep you awake and excited for the rest of the day, maybe. So the biggest problem I've seen when trying to do secure software development is that people don't want to do it because it sounds not so interesting or it's difficult. And so it gets left to later on in the process. And as you begin to get towards deploying your software into production, that first release, you go through your release planning checklist. You've had pull request reviews on everything, not the security side of things. And you've done capacity planning, and you're pretty sure everything will work. And then there's that little checkbox at the bottom that says security audit. And you go through to the security guy, who looks something like this. And he's very not happy with you and says, no, you're not allowed to deploy to production. You've done all of these things wrong. You're vulnerable to SQL injection. You've got buffer overflows. You're storing all your passwords in plain text. Yeah, and that's not a great thing. And that, having to delay deploying your software because someone says, no, you can't, you've written it wrong, doesn't feel great. And it tends to kind of reinforce the opinion that security is hard and annoying, and it just gets in the way. Oh, wrong way. Which kind of puts security up in the top right corner of this graph. As the time of your project goes on, the difficulty for security stays up at the top in the amount of difficulty it causes. But what I want to do is bring security to the front of your project, so you start doing it at the beginning. Now, this will not just move the circle to the left on this graph, but hopefully down to the bottom as well. We can bake security into applications in a way where it'll reduce the amount of work you have to do, and it'll be a more pleasant way to develop software. Because if something's hard to do, people probably don't want to do it. But if you make the secure way of doing something easier than the non-secure way, people will do it just because it's easier. And the fact that it's secure is a nice side benefit. And then you don't get angry security guys shouting at you. So as a quick show of hands, so I know, sorry, audience interaction. How many of you are, or stick your hands up if you're software developers? Okay, so basically everyone. And stick your hands up if you're a security developer or really, really interested in security. Oh, okay, that's more than I was expecting. So sorry if I get anything wrong. As Ian said this morning, we are just guys up on stage, and unfortunately it is usually guys. And this is just something I find interesting and I want to make better because I like making other developers' lives easier. So I'm going to talk about an application which I used to work on, which needed a lot of security love adding to it. So this wasn't at the beginning of the project, it was at the end, but we tried to go back and retrofit security. The application itself was a single monolithic code base, written mostly in C#. There was a database and a message queue. It was deployed to 5 or 6 servers and around 400 to 500 desktop computers. Multiple services, multiple applications, one code base, one shared configuration file with a connection string in it. Luckily, the connection string was encrypted, so it wasn't just in plain text on everyone's hard drives. But the encryption key was in the shared library that all applications had sitting next to them. So it wasn't so much as secure, but obscure. And so that's not great, because any one of those machines got any kind of bad thing happen to it, and these included laptops that consultants took home with them. So this was quite possible for any of this to get out into the wild. So what we wanted to do is try and make each of the services have their own connection string so that we could at least try and isolate certain parts of the system. It would mean we can also give different permissions to different services and maybe give certain connection strings read-only access. So to do that, we implemented this. I've written this as a TOML configuration file, but this was done in Octopus deploy. We had a single connection string parameterized with username, password, database, and host, and a default value defined for each one of these fields. Then each piece of software, like for in this example, the desktop one, had an override for what its username and password were. And the same again as we got to the worker service, we then gave that its own username and password. So we were able to migrate towards having separate connection strings for each application. The downside is all the problems that we created in the process of doing this, because we had to copy and paste passwords between SQL Management Studio and our configuration files. And something used to like putting in a non-printing space at the end of connection string passwords. And if you caught that, that was fine. But one of our connection strings actually had the non-printing space at the end of its password in the production database. And then we had the non-printing space in our configuration file as well. And this was fine until someone notices, oh my goodness, there's a non-printing space at the end of this. I'll fix that, delete, and now suddenly the application can't kind of talk to its database. And if you've got all this happening for each environment, and we had like a local environment, a dev environment, a test, a QA, a staging, and a production, because more environments is better. It's not. There's only one of those environments that gets hit by these kind of problems that breaks things, and that is obviously production. Because people fix dev as they do it, and they notice in QA, but by the time it hits production, people have stopped noticing. So while this was an improvement in the fact that we had unique connection strings, we were causing ourselves quite a lot of work. And having to remember to change the username and password for each environment we deployed in for each application was quite error-prone. Now, as this was in Octopus, we did have the ability to put in a deployment step, which would generate a username and password for the database on deployment time and write that into the configuration file for us. So that was an improvement, but it still means the connection string is in plain text, or encrypted-ish in plain text, on the machines that it was deployed to, and we wanted to avoid that as well. So we had a few goals for our project. We decided that this really wasn't the best way to do it. There must be a better way. So we wrote down what we wanted to achieve. The first thing we wanted to achieve was unique credentials, per environment and per application, and preferably per user, but not straight away. That was kind of a stretch goal. We didn't want any manual steps or scripts, especially if manual step meant copy and paste. We wanted everything to be securely stored, and preferably not on the machines being used. It can reside in memory, but we didn't really want this kind of information written to drives. We'd quite like an audit log, because then we can see who's using our connection strings, because at the moment we have no idea. And being software developers, we didn't want to write any code. Now, this is something that I pushed for this, because while I like writing code, the more code I write, the more code I have to support, which means the less code I can write. So writing code prevents me from writing code. So I want to write as little as possible, because I don't like bugs, and the more lines you have, the more chance for bugs you've got. So we decided to use HashiCorp's Vault product. Now, has anyone here heard of Vault? Again, hands up. Oh, quite a few. And put your hands up again if you use it. Not so many, right. So for those who don't know what Vault is HashiCorp is the company that makes things like Terraform and Consul and Nomad and Packer and all of these kind of cloud tools that you probably use, maybe one of. Vault itself is secrets as a service. It supports multiple types of secrets, so not only static ones, but it can do dynamic secrets, which is what we're going to be looking at today. It's got multiple compliance certificates, so it supports the FIPS 140-2, which is the Federal Information Processing Standard. I don't really know what that is, but apparently if you need to be compliant with that, this is. And it's highly configurable in how it stores its data. So it can be configured for high availability, and you can store data in backends such as Consul or etc. So as much as looking at things is fun, I'm going to try and show you it with some live coding. What could possibly go wrong? So I have a virtual machine running in the background, which just has Vault installed in it. And we're going to set this up to connect to a Postgres database and generate a username and password for a particular application. And then we're going to go through and improve it slowly. So the first thing I want to do is generate the database. So everything in Vault is configurable using REST API or the Vault client. The Vault client itself is using the REST API. So anything you can do with the client, you can do yourself. This makes it much more automatable than other products that I've looked at. So yeah, this is the database back end of it. Is this big enough at the back, by the way? I meant to check earlier. Let's just zoom in a little bit. There we are. So I've enabled the database backend, and this database backend can support multiple kinds of databases. In our case, we're going to look at Postgres, but it also supports MySQL, MS SQL, Oracle, and then all of the cooler databases like Influx and MongoDB and Cassandra and that kind of thing. So you can connect to anything interesting you want. Now we'll get back to what this particular part is a bit later, but the basic overview is that everything in Vault is path-based. So you'll notice that when we mounted the database connection here, it's at database/. This means that I can write a policy against that database and saying anyone is allowed to access anything under the creds path, and they're allowed to read from it, but not allowed to write. And this is what our applications will use later. We now need to configure Vault so that it can communicate with Postgres, because it needs to generate usernames and passwords. So we're using the Postgres database plugin, and we give this particular, we give Vault a username and password to talk to Postgres. Now in my case, I'm using the root account of my Postgres instance. Please don't do that in production. You should use a separate account so you can rotate those keys as well. And we have a connection string which has got merge fields in. This is not for Vault to connect to. Well, Vault will use this to do its own connection, but it'll also use this to connect and generate usernames and passwords for our new accounts, which we'll see in a minute. I'm using service discovery as well. I have Postgres registered into Consul. And because I'm a bad person, I've switched off SSL, because otherwise I have to deal with certificates, and that's too much security for one talk. And finally, we generate two different roles for our database. I've created a reader role and a writer. You could also do something like a migration role, which would have more permissions. So these two are identical with the exception of their creation statements. The reader is again created using these merge fields for the name and the password, which Vault will fill out itself. And then we also grant select on all tables. Whereas with the writer role, we also grant insert, update, and delete. So if you've requested a reader role, you can only select data. So let's see if I can remember the syntax to make this work. Let's clear that. So Vault, read, database, creds. Let's have a writer. OK, so that's made an HTTP request in the background to Vault, which then communicated with Postgres to create a new role. Everything is called role in this, by the way. It's really annoying. So it created a new user in the Postgres database with this lovely username and this as a password. You'll see here also that we've got a lease duration. So this particular set of credentials is only valid for 10 minutes. But you can renew it. And based on that configuration we did earlier, you're allowed to renew your credentials up to an hour, which we will have a look at in here. So if I refresh that, we'll see we've gained this, and here we are. So this user that's been created can connect as many times as it wants, and it's got a valid until date. So you can only connect with this user until this date elapses, at which point the database will stop you from accessing, but also Vault will come along a little bit later and delete this user as well, unless you refresh your credentials. Now, the refresh of credentials is important because we can now have credentials that are only valid for a very short amount of time. And we'll get to how to actually do refreshes and other parts later. So now that we've done that, we can actually run a C# application. So let's do this. Theme. Yep, good. A little bigger. There we go. So let's have a look at the program for that one. So to do this in C#, we're basically doing the same thing we did on the command line, except we're using the Vault connection library, which is down here. So I'm fetching from the environment the address of the Vault server. I'm fetching the root Vault token so that I can authenticate. And then using the client here, we fetch database credentials called reader. So this time we're going to generate a reader account rather than a writing one, and this just then uses that to select all of the roles out of the database so we can see what they are. Now I've already built this so we don't have to wait for that, I hope. That's apps bin. Hooray, it did work. So you can see here we've got the Postgres account, which is our root user. And then we have two accounts created. The first one is the writer, which is the one we created up here. And we've got a reader as well, which both expire, and the reader expires in about 10 minutes. Now, you might notice here that the authentication, the usernames have a lot of information in them. So we've got what Vault account created the database account, and what role it asked for. So we have the writer from the command line and the reader from the application. We then have a random generated hash, and then a timestamp for when it was actually generated. So there's a lot of information you can see just in the users here. The trouble with this is that these are both the root account for my Vault instance. And you really, really don't want to give your root token out, because then you might as well not have the Vault instance. So how do you prove what application is talking to Vault? Because if anyone can talk to it and request things, then you've not really gained any security. You've made it slightly more steps, but so congratulations, you've added latency to your pipeline. So with Vault, as I mentioned earlier, it's very configurable. There are many different ways you can authenticate with it. Developers on their local machines tend to authenticate using GitHub authentication. Applications in production environments, you can use things like Azure Active Directory or AWS IAM, GCP IAM. It's called IAM in GCP, I think. Whatever, GCP's version. You can also use things like TLS certificates, JSON Web Tokens, Radius. I'm not sure what Radius is. It's in capital letters, so it must be important. And a bunch of other things like LDAP as well. So it's very configurable. But because we're deploying individual applications, we're going to use something called app roles. You can think of app roles as being like usernames and passwords, but for applications rather than people. They're made of two parts, a role ID and a secret ID. Role ID is the username, secret ID is the password. The difference is multiple applications can have the same role ID, or rather multiple instances of the same application use the same role ID, and then they have their own secret which identifies them. So we're going to look at the pipeline of how I set this up, because I don't like manual things, so I try to have everything in my repositories. This includes what access I want the application to have. So we start off on the left side with our Git repository. In here, I have a configuration file which just mentions what policies I want to use. So the one we created earlier was the Postgres connector, but in this case, this unnamed application is also using a RabbitMQ connector. When the CI server runs, it updates Vault's role definition with what policies it requires. You'd do this usually after a pull request has been merged into master, and you should use trunk-based development because it's the best. Slight aside. You could do this without having manual outside the team. So if you have a security team, maybe they create your roles for you and say, right, your application role is called this, and you now have to hope that those policies don't change. Because if someone outside your repository has control of those policies, you could do a deployment or not do a deployment, and suddenly your application stops working because someone's changed the application role and said, right, it can no longer connect to RabbitMQ because they think that you're not connecting to it, but you really are relying on it, and now your application doesn't work. By keeping all the information in the repository, we have a single source of truth, and by automating it, we have all the audit logs of when and where it changed. So in this case, we'd have the Git commit history, the build log, and Vault's internal audit of when something changed. If you have a security team that doesn't like this, make them pull request or code owners for that area of code. They can approve and deny things, but it would mean that you can still keep your source of truth in your repository. The actual command for updating, I use something fairly generic, so it just uses the repository name. So here we have Authentication app role. Again, another thing called role. So this is the app role for our application. I've named it after the repository, and the token lasts 20 minutes with a maximum of 1 hour, and then uses whatever policies we named in the repository. Now that we've done that bit, when the build finishes, it triggers a deployment with Octopus. So maybe we've generated a Docker container or a NuGet package or something that we're going to deploy somewhere with Octopus. Octopus will now fetch the secret ID for the application from Vault. It'll write that into a configuration file and deploy the application onto this host on the right. The role ID comes from Terraform, or whatever software you're using to manage your infrastructure, be that Chef or Ansible or Puppet. It's worth noting that these two applications, Terraform and Octopus, only have permission to do one thing. Terraform can only fetch role IDs. Octopus can only fetch secret IDs. This is important as it means that neither of these applications has enough information to impersonate your deployed application. It's only when the application actually hits the server on the right does it have both pieces of information available to it. You can even go a step further and have Octopus able to generate a secret accessor token rather than a secret. Accessor tokens can be used exactly once to get the secret, which means when your application first starts, if it uses the token it's got and that doesn't work, it means someone's tampered with your pipeline. I've not normally gone this far. I tend to trust certain parts of my infrastructure. Like I trust the developers to actually change their own Vault policies rather than not trusting them. The trouble with this system is if you've got a lot of applications, you're going to have to put a lot of environment variables into your host. And Terraform needs to know which roles it's trying to write environment variables to, which means it needs to know every application that's going to be deployed into your host, which means your Terraform configuration for your generic host is now tied to what applications go on that host. You could read all roles out of Vault and just put all of the role IDs into the environment. But we're trying to lock the applications down to say this application only runs, this host only has enough information to run the applications it's supposed to be running. So if you don't like doing that, there's meant to be another slide. There is. OK, we'll demo that first then. I'll come back to that part in a minute. So let's look at app IDs. Let's clear that. So again, this is all configured off the command line. So the first thing we do again is we enable the app role backend. Again, there's many app authentication backends, but we're going to look at the app role. And in all of my genius naming, I've called this demo service because naming things is hard. A demo service is allowed to request a token for 20 minutes, up to an hour. It's allowed to use the default policy, which doesn't have anything particularly interesting in, and it's allowed to connect to Postgres. We then generate a role ID. So when you create the role, this ID is generated internally, and I'm now just fetching it onto the command line. So I'm now going to pretend to be Terraform, and I'm going to pretend to be Octopus. And to pretend to be Octopus, I am going to generate a secret ID for the demo service. So every time I run this command, I will get a new secret ID back. So let's now set up the application. So we'll first pretend to be Octopus. I'm going to copy that and go vi app. No, I'm going to change directory first. See, this is the fun of live coding. Bin app role vi. Excellent. So, writing this secret ID into the application configuration file is essentially what Octopus will be doing for us right now. And then we'll take, actually let's run the application like this first and see what happens. .NET app role access. And we should get an error, yeah. Value cannot be null, role ID. So we need to provide the role ID. That's here, copy that. And then we can pretend to be Terraform by doing export app Vault role ID. I hope I remember the name of that parameter correctly. So now when I run the application, all right, you can see here it connected again. We have the default Postgres role in the database, and now we have our two separate users. So we've got the root one, which we created off the command line earlier, and now we have one that was generated by an app role, and the reader access that it required, and again, it expires in 10 minutes. Now, hopefully about 20 seconds has elapsed. Yep, and you can see that the previous reader role has now disappeared. And the code to do that is basically identical. In fact, the main function is identical. The only difference that I had to make for this application is that I'm deserializing a JSON file to get my secret ID, and I'm reading the Vault role ID out of the environment. Rather than doing it with a manual JSON deserialization like this, I'd recommend using something like the Microsoft configuration library, so you can have strong type configuration, which is an entire separate topic. I will bang on about that for ages. And even so, I'm still trying to strong type it. So we just changed the authentication method to app role auth, and then the rest of the application is the same. But as I mentioned in the presentation, what if you've got so many applications and you can't write into the environment, or you don't have automatic control of your infrastructure? In the company where this original application was, we definitely didn't have particular control of our infrastructure. It was all manually created and everything was manually installed on it. And I don't want to have to keep manually pasting environment variables around because I get the same problems I had last time. So there is a trade-off you can make here. It is slightly less secure, and that's to have the developer take the role ID when it's created and embed that into the source code of the application. It still keeps the role ID and secret ID reasonably separate until you hit the Octopus phase of your deployment. So it is slightly less secure, but if you're not automatically managing your server infrastructure, this might be a better way of doing it. So again, it's a trade-off you need to make. So, who here uses Kubernetes? Hands up again. Oh good, only 2 or 3 of you. I don't like Kubernetes. This makes me very unusual, I think. So, I'm actually going to demo the next part using Nomad, because that's a better container scheduler. Does anyone use Nomad? No, there's no surprise. You should do, it's much better. I'm not paid to say any of this, by the way. I just think it's better. That was a bit of an extreme reaction to dissing Kubernetes. So we can simplify our pipeline a bit. If we use a container scheduler, so again, you can imagine the Kubernetes logo here if you'd rather. It does work from there. I've tried it, but Nomad is a little easier on me. So in the case of this, we build our Docker container and then deploy it to Nomad, and Nomad itself has the Vault integration to fetch your role IDs and your secret IDs for your application. Now, this does mean you have to trust Nomad to have integration into Vault, but it's a fairly high-trust piece of software anyway, so I'm fine with delegating that trust to Vault, to Nomad, because it means I don't have to worry about server infrastructure anymore. Now, as none of you've really used it, this is a very small snippet of a Nomad configuration file. It's not the prettiest to read, I'm afraid. Here we have the policies that we were mentioning earlier, so Postgres connector, and then we have a template file. Now this is written in the Linux app environment variable format. So we have a DB host with our console path in it. And then we have this integration here. This is the same as the command we ran on the command line to generate the credentials. So generate me a database reader. And we write it into this DB username and DB password field. The two JSON parts, because it's strings, it doesn't matter, but it makes it escape all of the data correctly. So if you have any strange characters that are not safe to just stick on the command line, such as backslashes, this will escape them for you. We write it into a secret file called file.env. The name doesn't really matter. And we mark it as an environment variable file. This means it won't get written to disk on the machine that actually runs the application, but it will be loaded into that application's environment variables. This is probably not making a vast amount of sense yet. So I've got another demo, because I like living dangerously with coding. Right, let's see how this works. Let's clear all of this out of the way again. So this time we're going to run a Nomad file. So let's do Nomad job run apps external Nomad file. Good. So while that's spinning itself up, let's actually have a look at the file. So this is a Nomad configuration file. There's not a huge amount to it that we need to worry about, other than we're going to run the .NET command. We're going to give it a path to our application. The application itself is going to come from this artifacts repository, and it's just a zip file. The application is hosted on my local machine, and the artifacts is just a Docker container that is an HTTP server. Got some resource limits, and then we have the Vault policies here. So again, we only want to connect to the database. We have the DB host and port coming out of Consul because I had Consul integration available, so why not? And then the username and password generated off the command line. The destination again is the environment and here. So with luck, we have one job running in Nomad. And that's the task itself. So this is the application that we launched. And if we look at the logs and zoom in a bit, big enough, we can see here that the same thing has occurred when we've run this application each time. We've connected to the database, we've generated a role, and then we've connected to the database and read all of our files, read all of our roles out of the database. Now, the really interesting part with this is when we look at the source code for the application. So we don't have a reference to the Vault client anymore. The application doesn't need to know about it. In fact, the only thing we're doing is taking all environment variables that are prefixed with db underscore and populating a connection string builder with it and using that to build the connection string. So my properties that I named in the file, by prefixing them as db underscore username, they match to the username property that's on this builder. So if we look at the builder, username, that now came from our environment variable that was filled out by Nomad with the Vault credentials, which gets filled out by this. Which means that our application code becomes much, much smaller because it doesn't have to deal with where the configuration came from anymore, as long as it's available in environment variables. Now, you could manually map this instead. Like I said, I've done this because it's as little code as possible. But if you wanted to be a bit more explicit, we could replace all of this with something like, let's do this, var builder equals new npg SQL connection string builder username equals, and then I had my environment variable called environment get variable db underscore username. I think that's how I called it. Yeah, so that would be equivalent of these lines below, except because I used automatic mapping, I didn't have to type all of this out. And I don't like typing. And the same goes for the password, obviously. And the beauty of doing this through Nomad is that I don't have to think about how to refresh my tokens anymore, because Nomad and Kubernetes will use the Vault integration, and they know when that token is due to expire. And as long as it's refreshable, it will generate a new token, write it into your environment variables, and then it can either restart your application or send a custom signal to it. So if you handle SIGINT or something, you can then respond to the configuration file changing, reread the variables, and now you can stay connected and your application stays running, which is a fairly little amount of work on your part to get short-lived credentials. I think it's probably a good idea to go through why I want short-lived credentials. And that's primarily because if a server gets compromised, the shorter time that my credentials are valid for, the shorter time that an attacker has to actually use them. Now, obviously, if you've got a really small window, you do pay the latency of having to fetch new credentials each time you need them. But you compare that against uptime of Vault. Now, Vault is highly available, but if you've deployed a single node of it, as long as your Vault node is up enough for your duration of your credentials so they're always available and never expire, you can generate very small windows of time where credentials are usable. And it limits your attack surface, something chronic, because we've seen all of these reports of like data being exposed on the web. People haven't secured anything. MongoDB's left open to the internet. Well, imagine if those credentials were only available for like 2 minutes or 5 minutes. Hopefully not much data would be siphoned out. Someone would try the credentials, they've expired, they'd probably give up. So the shorter the lifetime of your credentials, the better, to a point. You don't want them to expire instantly. The auditing side of this as well was one of our other goals. Now, audits in Vault are, like everything else, configured through the CLI. In this case, I'm using the file audit. Vault supports 3 different ways of auditing your information. That's a file, syslog, and a socket. So as long as you can read from a socket, you can make an audit backend that can receive information. There is one thing to note with audit backends. In a production environment, you should definitely use audits, and you need to use at least 2. If you use 1, you're asking for problems. The reason for this is Vault will, when it receives a request for a token or any kind of information, it will write that request to the audit log, generate the token, write the response to the audit log, and then return the token.